In this video, we're going to find points of inflection. And to find points of inflection, two things need to occur. The second derivative needs to be equal to 0, and there needs to be a change in concavity. No change in concavity means no point of inflection. So let's start by doing the first derivative. Our first derivative would be 1/3 x cubed minus 1/2 x squared minus 2x plus 1. Our second derivative would be x squared minus x minus 2. We're going to set that equal to 0 and solve normally by factoring. So we get an x plus 1 and x minus 2, which would give us possible points of inflection at -1 and 2. If I do a sign chart to figure out changes on concavity, to the left of -1 is -2. If we plug that into our second derivative for the x values, we would get a negative times a negative, which is a positive, so it's concave up over the interval from -infinity to -1. If we choose something between -1 and 2, let's say 0, we would get 4x a positive times a negative, which would be a negative concave down. Now notice we had a change in concavity at -1. That makes a point of inflection. So we have a point of inflection at x is equal to -1. If we continue and choose something to the right of 2 like 3, plug in, we get a positive, which is concave up. So again, we have a change in concavity, point of inflection also at 2. Our reasoning why is the second derivative is equal to 0, and we have a change in concavity. Let's do one more. So same thing, finding points of inflection. So our first derivative would be 1/3 x cubed plus x squared plus x minus 2. Our second derivative would be x squared plus 2x plus 1. Set our second derivative equal to 0. Solve. This one factors as a perfect square trinomial, x plus 1 squared. So at x is -1, we have a potential point of inflection. Now remember, this is very important. You must have a change in concavity here in order for this to happen. Well, we know that when you square something, it's going to be positive no matter what. So we have positive on both sides, meaning concave up on both sides. No change in concavity means no point of inflection, and our reason is no change in concavity.